Hello everyone, myself Pancham Singh, Assistant Professor in IT Department, AKGEC Ghaziabad. I am going to discuss the fourth lecture on Message Authentication Code. So in this lecture, I am going to discuss about what is the message authentication. In this lecture, I am going to discuss about the message authentication. So what is the message authentication? And in message authentication, basically what is the purpose before we are going to send the message from sender to receiver. So then how you will authenticate the genuinity of the message that is sent by the sender to receiver is authenticate the getting the message that is genuine, that is real message which is sent by the sender. So message authentication basically protecting message content, that is secrecy, by encrypting the message. So encrypting the message means when sender is sending the message, so how you will check the genuinity or secrecy of that message? Who will check the genuinity of the message? So sender will send the message and receiver will receive the message. Then how he can say the message he received by the receiver is correct message or genuine message? Now there are two important points are given here. Now consider how to protect message integrity. Message integrity means the message which are going to send by the sender and which is received by the receiver, that is secure message. And integrity means in between we are going to use the some secret key by sending the message and receiving the message. The key is known by the sender as well as receiver. If sender is sending the message, he will encrypt the message by the using the same secret key, and that secret key is also known by the receiver, and receiver will decrypt the message which is sent by the sender and get the same plain text. So this is the integrity. Basically integrity means in between the message which are going to send from the sender side and receiver side, the key which we are going to use, that is called the integrity. Now next point is that then three alternative functions used in this message authentication. Basically it is depend upon three important functions. The first function is message encryption. So message encryption means by using the secret key you will encrypt the message, and the message is converted into the ciphertext, and the ciphertext again decrypted by the receiver and get the plain text. Now next point is the message authentication code. Message authentication code means we are authenticate the message which is sent by the sender and received by the receiver, both are same. Next and last point is the function, that is called hash function. So the hash function is also part of the message authentication. I will discuss in detail. So what is the security attacks basically? So when I am going to discuss about the security attacks, so which type of attack will occur on the sender end? So security attacks will occur in different types. I am going to discuss one by one. The first one is the disclosure of message content. Disclosure of message content means if someone is known about the message, it means that he or she can easily attack on that message, attack on the sender message. Now second point is traffic analysis. So if you have good knowledge of the traffic analysis, then you can change the pattern of the traffic. This type of attack is called the security attack. Now next one is the masquerade, or you can say insert a message from a fraudulent source. When you are going to send a message, that is very important message, and some attacker they may be change the message or insert the message in between your message, that change the meaning of that sentence or message, that is called the masquerade. Now fourth point is the content modification. Content modification, for example, you are doing some project on doing one important project, and some hacker they have hacked your data, and they will modify their content. The content which you are going to send to the another label, another level of the team, then in between hacker will hack your data and they will modify the content. Next one is the sequence modification. For example, we are sending the packets in the serial order. Maybe sender has maybe attacker maybe hack your system and he will change the sequence order, or you can say he may be insert the packet, he may be delete, maybe reorder the packets. So sequence modification, your packet sequence is going to change by the hacker. Now next one is the timing modification. Timing modification, for example, you have sent the data packet and that timing is given and sender has changed the timing. Sending timing means, let's say you are going to send the packet on that particular time and some attacker has changed your sending time or pre-time. Pre-time means pre-time is also known as replay, delay or replay. So they can change the time in the form of they may be change the time of the packet receiving late or previous. That is called the timing modification. Now next one is the source repudiation and destination repudiation. Source repudiation, may attacker will change the source of the receiving message. For example, you are sending the message from that particular place, या particular email ID, या particular organization. Attacker has changed the source repudiation of the message. Similarly, he may change the destination repudiation. So these type of attack basically occur in the message when sender is sending the data from one place to another place. Message encryption. Message encryption by itself also provides a measure of authentication. So message encryption basically when sender is sending the message and receiver is receiving the message, so how they can check the genuinity of the message. So by using the symmetric key cryptography techniques. So in symmetric key cryptography techniques, here is a secret key that is shared among between the sender and receiver, and sender and receiver both know the secret key. Sender is sending the message and encrypting by using the secret key. That encrypted message will receive at the end of the receiver, and receiver will decrypt the message by using the same secret key, getting the plain text. So symmetric key cryptography is very simple. In both end, sender and receiver both know the common key, that is secret key. Now message encryption in another way. If you are going to encrypt the message, so you can encrypt the message in another way. So there is, if public key encryption is used, if you are using the public encryption, so encryption provides no confidence of senders. That is called authentication. Since anyone potentially know public key, so maybe public key, as you know very well, public key is a public key where everyone is know that the common key. But how you can change the key, like you are using the public key and you are using a private key. So how you will send the message and which key will use for the encryption and who will use for the decryption key. So both key by share by the sender and receiver. For example, if you are sending the message, so sender signs message using their private key. Similarly, the encrypt with recipient public key. So they are using the reverse key, like sender is sending the message, sender is using the private key of B, receiver is using the public key of A. So in this way they can encrypt and decrypt the message. So I am going to discuss by the example. So here is the figure. In the figure, by using in the first figure, that is called the symmetric encryption. Symmetric encryption basically used for confidentiality and authentication. Confidentiality and authentication. So in confidentiality and authentication means the message is confidential and authenticated by the sender and receiver. So for example, sender is sending the message the message is encrypted by the secret key, that is K, and you are getting the message in the form of EKM, that is encrypted message, by using the secret key, and receiver is using the same key to decrypt the message and get the message. It means that sender is sending the message that is encrypted by the key, and that encrypted message is again decrypted by the receiver by using the same key. This is the first example where we are discussing about the confidentiality and authentication. In second figure, a sender is sending the message, so sender is using the public key of B. So sender is using the public key of B, so it will created into the encryption part. Encryption means sender is using the public key of B, and that encrypted message B will be decrypted by the private key of B. So this is the second way we can send the message from sender to receiver. So in the first case there is a common key, but in second case sender is using the public key of B and receiver is using the private key of B for decryption. So this is the public key encryption confidentiality, that is called the public key encryption confidentiality. Now in the figure 3, that is figure number C, sender is using the private key of A, and that encrypted message will be decrypted by the receiver by using public key of A. So this is the another way we are sending message and receiver will receive the message in the third way, that is called public key encryption, authentication and signature. And last one is the most complex way we are sending the message and receiver is receiving the message. So how many attempts we are going to encrypt the data and decrypt the data, and we are getting the actual message or actual plain text. So in this diagram, sender is sending the message M, that is encrypted by the private key of A. The message is encrypted, and that encrypted message will be again encrypted by using the public key of B. That encrypted message will be received. So you can say here two level of encryption are used. The inner layer encryption is by using the private key of A, and outer layer by using the public key of B. So this is the two layer of encryption. So the message is very complex. If hacker want to hack that message, so they cannot easily access the message, they cannot easily hack the message. So similar way we are decrypting the message. So in the first decryption we are using the private key of B by decrypting the outer layer of encryption. By using the second decryption, receiver is using the public key of A, decrypting the inner side of encryption. So there are two level of encryption, as I have already discussed. Two level of encryption is here. One is the inner layer and second is the outer layer. So outer layer will be first decrypted and inner layer will be second decrypted. Then receiver will get the actual message. So in this diagram basically we are going to provide more security in terms of confidentiality, authentication and signature. Now I am going to discuss about the message authentication code. So as you know that what is message authentication code, why it is required by the sender. So message authentication code basically generated by MAC function C that create a small fixed size block. When we will use the message authentication code, so message authentication by using by the MAC function, and MAC function basically used to create a small box that depending on both message M and shared secret key. The shared secret key and message are represented in the form of MAC equals to secret key plus message. And next point is MAC is appended to the message M. So that MAC is appended with message M and sent to the receiver end. And what receiver will do? Receiver will check that MAC function. If the MAC function is similar, then receiver will decrypt the message. Otherwise, receiver will refuse the message. So receiver is only first check the genuinity of the MAC function. If MAC function are same, then he will retrieve the message, otherwise he will refuse the message. So in this diagram, it is very clearly explained that if sender is sending the message and that message is mixed up with by MAC function, MAC authentication code, that is C, and it will be clubbed between the message plus MAC. This message plus MAC will be sent to the receiver end, and receiver will compare the MAC authentication code. If MAC authentication code is same from sender to receiver, then receiver will retrieve the message and get the actual message. So now we are going to explain one by one in this diagram. In the first figure, message authentication, basically how it will work. So first message will send by the sender, and sender will use the message authentication code, and thus message plus MAC authentication code will be sent to the receiver, and receiver will similarly check the message authentication code. If he will get the same message authentication code, then he will retrieve the message. Now in second diagram, we are using the same process. Let's say message will send to the receiver end. So message will send by using the message authentication code, and that message authentication plus message will be encrypted by the secret key K2, and now this message will be encrypted by the secret key K2, and we are getting the encrypted message, and that encrypted message will be decrypted by the K2 by the receiver, and after that receiver will check the message plus message authentication code. If message authentication code is same, then the receiver will get the message by decrypting the secret key K1. In the third diagram, that is in which sender is sending the message, and the first level message will be encrypted by the using secret key K2. That secret key K2 will encrypt the message, and that message will go for the next level, and we are using the message authentication code on encrypted message. And now we are clubbing encrypted message plus message authentication code, move for the next level. In next level, it will be received by the receiver end, and receiver will decrypt the message that is encrypted by the sender at the first level K2. So message will be encrypted message will be decrypted by the receiver only before checking the message authentication code. So first receiver will check the message authentication code. If it is genuine or if it is same, then he will decrypt the message and get the actual message. So in the diagram in number third, yeah, you can say in figure C, message authentication and confidentiality authentication tied to ciphertext. So we are giving the security levels, we are increasing the security levels from level 1 to level 2 to level 3, so that hacker cannot easily hack the message which is generally sent by the sender. So message authentication codes can also use encryption for secrecy. So as I have already discussed about, the message authentication code is nothing but it is a type of message which is clubbed in between the message and will be sent to the receiver end, and receiver will check the genuinity of the message authentication code. On the basis of he will decrypt the message. MAC properties. So how MAC basically work? So I have already discussed, a MAC is a cryptographic checksum. So MAC is nothing but it is a cryptographic checksum What is checksum basically? Checksum is nothing but when we are going to send a message, so we will add some extra bits in the form of the checksum. So MAC equals to CKM. CK means that is MAC authentication code with message. Confidences variables length message M using a secret key K to fix size authentication. So I have already explained if you are going to send a message, so message with MAC authentication code, that is called that will increase the security of the message. It may be varies by 100 bits message and 20 bit MAC address, MAC access. So why MAC is required basically? What is the importance of the MAC? Taking into account the types of attacks need the MAC to satisfy the following. So we required MAC by modifying the message by inbuilding the checksum. So message with MAC, it will create the more accuracy when receiver will receive the message, and sender will understand this is the whole message and he will get confused, because in that message plus MAC both are sent from the sender end to receiver end, and receiver understand about the message and MAC. So in the first point, knowing a message and MAC, if infeasible to find another message with same MAC. I have already discussed this definition. MAC should be uniformly distributed. So if you are sending sender and receiver using the same MAC, it must have the equal bits or byte. MAC should depend equally on all bits of the message. I have already discussed the amount of message authentication which is added in the message must be same as the receiver. Let's say you are adding 8-bit MAC message authentication. So 8-bit message authentication also received by the receiver end. They will check the position of the bits. After that, he will retrieve the message and get the message. What is the hash function basically? So another important function for message authentication, that is called hash function. So condenses arbitrary message to fixed size. So we will fix the size of the message. So now I am going to discuss in detail by the figure. So in message authentication by using the hash function, so message is encrypted by the message is sent by the sender by using the message authentication code, and this message will again decrypt by the receiver by using the checking the message authentication code and decrypting the message by using the secret key. So this is the first level of hash function by using the message authentication code and getting the message. Now in the second level, we are going to increase the security level. So in the second level, sender is sending the message. That message is clubbed with the message authentication code, that is K1, and this message will be encrypted by the using the secret key K2, and this whole encrypted message will be decrypted by first by using the secret key K2, and again we are getting the inner side message, that is message plus message authentication code. Then what receiver will do? Receiver will check the message authentication codes. If message authentication code are similar, then he will verify या authorize कि this message is genuine message and receive the message. In the next level, when you are going to send the message, so message will encrypt at the first level. So in the previous level, you are sending the message will club with the message authentication code. So we are going to provide more security, or you can say more level of encryption and decryption by securing more, by creating more security level on that particular message. So message will send, or you can say message is first encrypted by the using the secret key K2. That secret key K1 by using the message authentication code, that is K1, will be clubbed by encrypted message plus message authentication code will send to the receiver end, and what receiver will do? Receiver will decrypt the message by using the secret key K2, and before decrypting the message he will first check the message authentication code. If he will get the same message authentication code, then he will get the permission to decrypt that message by using the secret key K2. So here are three level of security before you are going to send the message from one level to another level. Way in which a hash code can be used to provide message authentication code. So in which way you are going to use the message authentication code, and we are going to send the message from sender to receiver. So in figure first, we are getting the message will send to the from sender to receiver. So message will be clubbed by the message hash function. That message plus hash function will be encrypted by using the key K, and this message will be again decrypted by the receiver by using the same key, and same key, and again receiver will check the hash function. If he will get the common hash function, then he will say that he is getting the correct message, accurate message. In the second level, again we are going to use the second level of security. Here message is sent to the sender to receiver. So message will club with the hash function. That hash function will be encrypted by the using key K, and it will club with the message, and that message plus hash function will be checked by the receiver end, and receiver will check the hash function. If that hash function is common, then he will decrypt the message and get the actual message. So similarly in figure C, we are going to increase the security level of the message. Here we are sending the message, and message will be by using the hash function, we are creating the more level of security, and similarly receiver will check the message plus hash function and compare. If he is getting common, then he will decrypt message and get the message. So by using the different level of hash functions, we are increasing the security level of the sender. Hash function properties. A hash function produces a fingerprint of some file, message or data. So hash function basically applicable on some file or some message or some data. Now in the second point, condenses a variable length message M to a fixed size fingerprint. Fingerprint means a sender is sending message, they are using the fixed message. On fixed message he will apply the hash function and convert in the form of the encryption, and after encryption he will decrypt the message and get the actual message. So here is the comparison and the last PPT. In this last PPT, basically our purpose is to define the hash function and why it is required by the cryptography. So requirement and description. So variable input size, when we discuss about the variable input size of the data, hash can be applied to block of data of any size. So this is the additional feature of the hash function. Now in the second point, fixed output size. H produces a fixed length output that is produced by the hash function. In terms of the efficiency, hash function is relatively easy to compute for any given X, making both hardware and software implementation. Premise resistant. For any given hash values H, it is computationally infeasible to find Y such that Hy equals to H. So for different value of y, we can get the hash function. In the second class, collision resistant, it is computationally infeasible to find any pair of collision like hx equals to hy. So if you are getting the two different variables x and y, so if you are going to compare at the collision level, then it will represent hx equals to hy. And last one is the pseudolens. Output of h meets standard test for pseudolens. So these are the functions and description of the hash function, and why hash function is important in terms of the fixed size and variable size of the output length. Thank you.